So we'll look at a little bit more advanced probability in this particular video. What's called conditional probability. So let's say that we took this sample of students around school, separated it by boys and girls, and then we looked at some of the reasons or their focuses in school. So whether it was grades, friendships, or athletics. Also, we can start pulling some probabilities. So what's the probability that we randomly select a student out of this group that's a girl? So in that case, we go over total number of girls divided by total number of students, and that'd be 0.525. We switch it up. Let's say we want to look at the probability we get someone that's a girl and popular. So out of all these students, what's the probability we get both? Well, that's where we go to the overlap of girls and popular, and we do 91 over the total of 478, which is 0.19. Next up, we go probability that they are at school for sports. So the probability that somebody's focus is sports in school. At that point, we go to that total for sports and divide by overall total of 478 for a probability of about 0.19, 0.188. Where conditional starts to change a little bit is all of a sudden we're told something is true before we kind of begin. So what's the probability of the individual's focus is sports, given that we know that they are a girl? So now all of a sudden things have changed a little bit for us, where we actually know something right away about it, is that we know that we picked a girl already. So in other words, we're going to be in this row right here. So we're going to look at there are 30 girls that are focused on sports, so 30 out of 251 is 0.120. At the same time, all of a sudden we can look at what's the probability of it's a girl given that they play sports. So this time we know that they play sports. So we're going to pull from this column. So our new denominator is 90, so it's 30 out of those 90 for 0.33. So these bottom two problems right here, these are what are called conditional probabilities. And the notation for conditional, probability B, you get that vertical line in A, and that's translated as a probability of B given that A has occurred. The formula for this, you're going to take the probability that both occur at the same time, the and divide by the probability of A. So if you look very carefully, whatever comes second in your condition, that's the probability that's in the denominator. So for us, probability of sports, given that it's a girl, we'd want the probability of girl and sports over the probability of a girl. So for us, girl and sports, that'd be 30 out of the total of 478. There's your numerator, and then the probability that we select a girl at random. Out of the entire group, probability of girl is 251 out of 478. And what we should notice here is that those 478s are actually going to cancel, and we're left with kind of the way that we did it on the previous page, which is 30 out of 251, which we saw right here, that 30 out of 251 for that particular example, 0.120. So in order to start setting some of these things up properly, though, we want to make sure we have a feel for what is a disjoint and or mutually exclusive event. Interchangeable words, and basically it's just something that has no outcome in common. So one of the ways to kind of look at that, we can look at an example that's not mutually exclusive. So houses in a neighborhood. Some houses have homes, some have pools, some have both. So you got this group right here that just have a garage, some that just have a pool, and some that have both. So these two things would not be disjoint, or they're not mutually exclusive. An example that is mutually exclusive would be the color of the light of the traffic at an intersection, the traffic light. You can't have a half red, half yellow. Other mutually exclusive things, the color of M&Ms in an M&M bag. You can't have an orange and a red at the same time. So these are disjoint events. So if they are not disjoint, this is kind of an addendum, or a better version of your addition rule, excuse me. So the probability of A or B, right, that's the union. Or yesterday, or a few days ago, previous video, we talked about or meant plus, and that's the same case here. We're still going to add them together. However, we got to account for all of a sudden, if we do A plus B, so all of a sudden here's A, and we're going to add that to B, what you got to realize is we've actually double counted this group in the middle when you did A plus B. So that's why all of a sudden they're going to take out the intersection, because you don't want to double count it. Another way to kind of think about it, A is some group that consists of 1, 2, and 3. B is a group that consists of 3, 4, and 5. Well, if we try to combine those two groups together, A or B, it's 1, 2, 3, 4, and 5. However, if you don't think carefully about this, if you just added A and B, if you just did group A right here, plus group B, and then all of a sudden you can see 3 is in both groups. You could double count it, and there it is right there. There's a 3, there's a 3. So what we need to do is go back and subtract the overlap once in order to make sure that we don't double count it. So this is a formula that's very, very useful to us. It comes into play a lot, and really it's kind of the better version of the addition rule anyway, so that's one you want to memorize. How we're going to use some of these conditional probabilities. So there's a police report that says 78% of drivers stopped on suspicion of drunk driving are given a breath test, 36% get a blood test, and 22% get both. One of the ways we can start to organize this data, because there's overlap, is a Venn diagram. So let's call event A breath test, event B blood test. So 78% are going to fall into breath test, 36% into blood test. Well, right away there's kind of an issue, because if we try to figure out what's the probability of a breath or a blood test, if we add those two together, 78 plus 36 is well over 100%. So what we need to do is account for this 22% that took both tests. So we'll put it in the middle. This 78% accounts for the 22% that's already there. So there's a chunk of people that we're missing all of a sudden that just took the breath test. So we'd take that 78%, we'd subtract the 22% that's already accounted for. And the same thing with a blood test. If all of a sudden, if this whole group is 36%, 22% of the people are accounted for in this overlap, which means only 14% got one of the tests. So the probability of breath or a blood test, one way to kind of look at that is you could do the probability of only breath, 56%, plus the probability of only blood, 14%, plus the probability of both, which would be 92%, which means that the probability that somebody had neither test is 0.08. This previous example that I kind of skimmed over very quickly, the probability they get blood or breath but not both, well, that'd be this 56% plus that 14%, which would be 70% of people get one test or the other but not both. The probability of no test, again, if we added up all three of these values, only breath test, only blood test, and then both, then we'd end up with 92%, and that means 8% of people didn't get a test. What's the probability that randomly selected DWI who has been given a blood test will also be given a breath test? This is something you're going to have to start paying very, very close attention to, because this is a setup for conditional probability. So in other words, if we call A blood test and B breath test, we know, right, read that carefully again, what's the probability they have been given a blood test, they're also going to be given a blood test, or breath test, excuse me. So we know they've already been given a blood test. So in other words, what's the probability that given that they've had a blood test, they also have to do a breath test? So if we look very carefully at that, A and B here, so maybe we kind of do this in terms of what we got going on. So probability of breath and blood test, and then blood comes second, so this will be probability of just a blood test, or the probability that they're given a blood test. And so we can see the probability of both is 0.22, and then the overall probability of getting a blood test was this whole circle. So that's 0.22 plus the 0.14, which is 0.36, and 0.22 divided by 0.36, 0.61. So there's a 61% chance that if they've already been given the blood test, they'll also be given a breath test. So conditional probabilities, however, I think can become a lot easier if we will just go ahead and set up a table to do those. So to set up this table, you're going to do breath test, blood test, yes, no column for both, and then total, and a yes, no row for blood test and total. So this 22% took both tests. That's going to come into play here in just a minute. So first off, the bottom right-hand corner is going to be 100%, because all probabilities will add up to 100. This 36, so 36% of people had a blood test. This 78, because 78% of people had a breath test. There's where the 22, yes and yes, they had to get both. And it's at this point that we can start filling in the gaps, where this entire row right here must sum to 36, so 0.22, 0.14. This entire row must sum to 0.78. That's how we're going to get that 0.56. And if you want to think about this for just a minute too, kind of erase some of my marks, if it'll let me. If we start here and we start using our brain a little bit, well, if 36% of people were given a blood test, that means for us that 64% of people did not receive a blood test. If 78% of people got a breath test, that means that 22% of people did not get a breath test. Now we can start filling in the gaps. This yes, this 22 plus whatever this number is here has to sum to be 36. So the missing gap here, in other words, they got a blood test but they did not get a breath test, was 0.14. Here, this 0.22 and then this number need to add up to be 0.78, which means that 22% received a blood test but did not, received a breath test, excuse me, but no blood test. It'll be 56%. And then if everything plays out right, this number right here should make all of the sums kind of work together. And sure enough, that's 0.08. And we already kind of decided the probability they didn't get either test, so that's a no and a no, would be 0.08.